all that can be altered. So general form of an exponential function, not shifted or anything, that's what we were graphing yesterday, is just y equals ab to the x. That's just the general form. So the form I'm going to give you today is going to be similar to the equations that we're going to graph. So that's just no shifting of any kind. Your asymptote would be y equals 0. Now, today, I'm going to write y equals ab, and my pen is going to die on me immediately here. ab. Now, if you have an exponent, we're not going to do any stretches or shrinks. We're just going to do shifting left or right or shifting up or down in this class. If you have a shift in the graph going left or right, it's going to be represented in the exponent. So it's just y equals ab. If the exponent, I'm going to write down x minus h. That h is going to affect the graph going left or right. I'll write this in a second. Let me just finish writing this. And then the other possible thing that could shift the graph would be if we had, this is not in the exponent, just a number added to the side. I'm going to use that to represent with k. Now, if we did quadratics, absolute values, square roots, cube roots, all these follow the same rules, and usually they use h and k in those formulas, which is what I'm using those for here. But whatever is with the x affects the x. So this is going to affect the graph in a shift left or right, and I'm going to write down the opposite way you think. So for example, if that was like x plus 4, it actually goes to the left 4. If it was x minus 5, it actually goes to the right 5. So when it's with the x, that's for any type of a graph, when you're doing a transformation of any kind, if it's with the x, it's going to be the opposite operation of what it looks like. Now, the k out here, that affects how the graph moves up or down. And this will just be exactly the way you think. So if I've got like plus 4, it's going to take the graph and shift it up 4. If it's like that and the k value said minus 3, we would take the graph and shift it down 3. So outside, that's going to affect your y. Now, the other thing is, and I'm going to jot this down, if you do have something added or subtracted to the side, that is going to affect where your asymptote is. So I'm just going to write down y equals k. It'll be a horizontal line just like it was yesterday. What? Has somebody got music going or something? You hear that? Okay, thank you. All right, that'll be your asymptote. Okay, now if nothing is added or subtracted to the side, it'll just be like it was yesterday where it was just y equals 0. But if you have something added or subtracted, that will actually be the number for your asymptote. Okay, does anybody have any question at the moment? All right, now here's what I did. I have 2 different graphs here that we're going to do, and it's just 2 different ways to shift the graph that I actually have in the middle. So we're going to graph this guy here and this guy here. And what I would call like your parent function is in the middle already graphed for you, just so you can kind of see what the shift would do. So here in the middle, this is just a graph of y equals 3 times 2 to the x. I think we graphed that in a couple of the questions that we did on our last set of notes. Now, here's the deal. If you look at the equation, I can tell you right away how the graph is going to be shifted. And if I've got something added or subtracted to the side, exactly what it looks like, just copy it down. This is plus 5. So it's going to take this graph that I have here in the middle, and it's just going to shift it up 5. That's all it's going to do. Because I just have the x right there, there's going to be no shift of any kind left or right. It's just an x, so there's no shifting left or right in that graph. We're going to just go up 5. Okay, so what I would do, I'm just going to make a table just like I did yesterday, and you guys feel free if you want to grab your calculator. If that is just a plain x, I would put 0 in the middle of the table, do a couple numbers smaller, couple numbers bigger. I usually just do like -2, -1, 0, 1, and 2. And then I'm going to grab my calculator, or you can plug it in by hand. It is completely up to you how you want to do it. but I'm just going to hit, I'll walk you guys through because I can get all 5 of those points at once if I have my graphing calculator to help me out. So if you hit y equals, I'm going to type 3, and then I'm just going to put the 2 in the parentheses just like it appears in the problem. You use the little caret button here, which is like, it's right above the division key. So it looks like a little triangle with no base. That gives you your exponent. Type x. Now this is a little different from yesterday because I have that plus 5. If you have a calculator like mine where you see that x in the exponent, you have to come back down on the level with the rest of the question. I'm literally just going to use like the arrow keys that are right here. Just use the right arrow. That'll bring it down so it's on the level with the rest of the question. If you have an 83, you don't have to do that. But if you have an 84, you're just going to just use that little right arrow key and then go ahead and put your plus 5. That's all you have to do. You just have to make sure you're not in the exponent when you do that. So 3 times 2 to the x and then plus 5. Once you got that, just hit second graph, and that should give you a whole table, and you can scroll up and down, and if anybody needs help with any of these, I will be happy to help you look at your calculator. But especially if you keep going negative to see this, these numbers get closer and closer and closer to 5 as you go, but they actually never touch it, never go over it. I don't need all those values there. We're going to go this way here. So at -2, it says it's 5.75. At -1, you got 6.5. At 0, you have 8. At 1, you're at 11. And at 2, you're at 17. Now, these graphs are just going to require you to plot a minimum of 5 points. If you want to put more, that's totally fine. But as long as you have at least 5 points, we should be good. And forgive me, I'm going to zoom out so you guys can kind of see I just made these graphs really huge, and I probably didn't need to do that. Now, my asymptote is going to be, I'm going to write that under the graph, y equals 5. And I'm going to go ahead and put that on the graph in the version here. Horizontal line, I call it horizontal sometimes to help me remember it. And that is y equals 5. And you guys saw when I was scrolling in the table, we're going to get really close to that, but we're never going to touch it, never going to go over it. What I'm really doing, I'm taking this graph in the middle here, that parent function, we're just going to take everybody and move them up 5 units. That's all we're doing. And so it'll be just shifted up. Now, if it's not on a nice point, like a lot of these were decimals, just do your best to estimate. So like -2 was at 5.75, so I'm just going to kind of guess that. -1's at 6.5. 0.8 will be a nice point, 1.11 will be a nice point, and 2.17 will also be a nice point. And when I draw this, you can kind of get the general idea of the shape there. It should be the same exact shape as this one in the middle that's graphed for you. Just when you draw it, just do that kind of that J, get really close to that asymptote, but don't touch it, don't go over it, just the best you can. And that should be the general shape of that graph. It should be the same shape as the one in the middle. We're just scooching everything up 5 points. And every single one of these, every exponential, doesn't matter what I'm telling you about, how we shift it, anything, every single exponential has the same domain. It does go left and right forever. So -infinity to infinity, or if y'all want to put that all real number symbol, that's totally fine with me too. Whichever is easier, but that will be true for every single exponential. Now, let me ask you this. What would the range be for this graph? Because it's different than what we were doing yesterday. 5 to infinity. It's going to be, you don't touch any part of the graph till you get to that asymptote. So when you do your range, it should just be asymptote to infinity. And we don't want to use a bracket on the 5 because you don't actually touch the 5. So just make sure you use a parenthesis with this. And that's all you have to do. Is anybody having a question so far? Okay. Now, the other graph I have up here at the top, let me zoom back in on this so I can read it a little bit better. Okay, bless you. Now, this one just has a shift, in this case, to the left. So I don't have anything added or subtracted to the side there. So you absolutely don't have to put this, but you are not going to shift up or down here. So the asymptote for this graph is going to be like it was in our last lesson, where it's just going to be the x-axis, which is y equals 0. There's no shift up or down. So in that scenario, the x-axis is going to be your asymptote. Now, this is a little bit tricky here. remember what I was making you, or what I was telling you at the top, when it's with the X, it's actually the opposite of what it looks like. And so this is actually going to go left 1 from this original graph. All right, and so the other thing I want to tell you here, when you make your table, like that would, I'm going to take everything and go to the left one, so that would correspond to the -1 that I just jotted down there. When you make your table, what you want to do is you want to use that value as the middle of your table. If you have a shift left or right, when you make those 5 points, whatever would set that equal to 0 and the exponent there, that's what I would use in the middle of my table, because that's now the new middle of your graph. That's like the new y-axis. All right, so it would be like, and you don't have to put this on the graph, but x equals -1 would be like your new middle instead of the y-axis. So when I make my table here, I just take that value, -1, and I put that in the middle. And then I just do 2 smaller numbers. So in that case, -2, -3, and then I do 2 bigger numbers, and that would just be 0 and 1. Whenever you have a shift left or right, you're going to alter your table a little bit to give you a better idea of what the graph would look like. If it doesn't shift left or right, just keep it like that -2, -1, 0, 1, 2. But because I'm shifting it a little bit, I'm going to shift my table a little bit, because it affects the x values. Okay, so now on this one, I'm just going to start over from scratch real quick and type this equation in. If you have an 84, like I have on my screen right now, when you do the exponent, you can just type x plus 1. Like I can see the x plus 1 in the exponent. If you guys have an 83, you have to put parentheses around that x plus 1 in the exponent. Otherwise, it won't do it right. Okay, so if you can see it in the exponent, you're good. If you have an 83 and you can't see the exponent, if it's on the same line with the rest of the question, just put parentheses around that. I will help you with it if you're not getting the same thing I'm getting for my table. Okay, once I type that in, just hit second graph, and that'll give you your table. And I'm going to start here. I'm going to look at -3 is about 0.75, -2 is 1.5, -1's at 3, 0's at 6, and 1 is at 12. And if you guys want to I'm just going to have you look at the parent function here in the middle here just real quick. So on this graph, I have the point 0, 3. Now on this graph, it's at -1, 3. It's just taking that point and shifting it over one spot is all it's doing. On this graph, I have the point 1, 6. On this graph, it's shifting it over so it would be 0, 6. If that makes sense. Now the other points are kind of decimals there, so they're not the easiest to see. Or I could do the 12 though. Where's this one at? This one's at 212. So on my graph, it's at 112 when I shift it. So it's just going to shift it back just a little bit is all it's going to do. I'm going to come down here and graph it on the actual graph I got for you guys, but it just shifts everything over one spot. It's a little trickier to do when you've got the decimals, but those nice numbers, you can kind of see that on that parent function. So I'm going to draw my asymptote here. Should be, there was no shift up or down, so the x-axis is just going to be your asymptote, that y equals 0. And I'm going to jot these down while I'm doing this. The domain, every single one of these, it does not matter how we shift it. It's going to go left and right forever, so you'll cover the whole x-axis. And then if you guys want to just do your best, a couple of these are decimals, but some of them are nice numbers. Just kind of plot these points. So like I've got -3.75, -2's at 1.5, -1's up at 3, 0's up at 6, 1's up at 12. Same general shape as what we just had there. We're just going to take everything and just scooch it over one to the left. That's how that would alter. Now, your range here is not affected by a left or right shift. The range would only be affected if you have up or down. So the range here, you don't start touching the graph till you hop over 0. So this is going to be 0 to infinity, just like we were working on in our last lesson. So not shifting up or down, so my range should just be 0 to infinity. Anybody have any questions? Okay. Now I have one more on the back. This one is decay. The two on the front were the same function. Both of those were growth. This is decay. And I think I can get this all on the screen at once. Maybe, maybe not. Okay, whatever. Let me zoom back out. Here is just y equals 4 times 1/2 to the x. Let me just write down the asymptote, domain, and range for this real quick. So asymptote, there's no shifting involved, so it should just be y equals 0. The domain for every single one of these, it goes left and right forever, so negative infinity to infinity. Now the range for this, you don't touch any part of the graph till you hop over that asymptote. So it would be 0 to infinity. That's the non-shifted version. Okay, now we're going to shift this. So the graph we're going to do says y equals 4 times 1/2, and then to the x minus 2 minus 3. I have two things going on here. So with the x, see it's x minus 2 there. So this would go the opposite way you think, right 2. Now, if you're moving left or right, I would alter the table. And so I would put that value that sets that equal to 0 is just going to be 2. Put that in the middle of your table. Make this bigger so we can read it. Okay, so I'm going to put 2 in the middle of my table. And then just do 2 smaller numbers. So I'd do 1 and 0. 2 bigger numbers, I would do 3 and 4. You can pick whatever values you want. You just have to have 5, but I would always tell you, if you have a left or right shift, whatever sets that exponent equal to 0, put that in the middle of your table. That'll give you a better idea of the shape of the graph. Now, the negative 3, this is going to affect the asymptote, but that's going to shift the graph down 3 units. So if I'm looking at the graph here, I'm going to scooch this up just a tiny bit. I'm going to just go ahead and draw my nice horizontal line at negative 3, and that's actually going to be my asymptote. So we're going to get really close to that, never touch it, never go over it. And it should take the same general shape as this graph that we've got here. Everything's just going to move down 3 spots. Okay, now I just want to show you something real quick when you type this in. So I'm going to do 4 in my y equals 4 times 1/2. I'm just going to put 0.5. It's just less buttons to push. And then when you do the exponent here, and then you also have the number on the outside. Okay, so my exponent, if you have an 84 and you can see this, just do x minus 2. Make sure you're using the minus key. You do have to arrow over to get down on the level with the rest of the question to put that minus 3. And make sure you're using a minus. Don't use the negative key. Make sure you use the subtraction key. If you have an 83, the only thing I would do differently, I'll just retype it in mine real quick. I'd just do 0.5. When you do your exponent, when you hit your little caret button, just put parentheses around the x minus 2, and then go ahead. You don't have to use the arrow to get down on the level with the rest of the question. You can just hit subtract 3. But it never hurts to put parentheses, and if you have an 83, you need to. Okay, then once I got that, just second graph to get my table. This one I started at 0, so 13, 5, 1, negative 1, negative 2. If you wanted to keep scrolling down and looking at the table, you see these values, they get closer and closer to negative 3. It's like negative 2.9. It keeps going down. It gets closer to that, but it's never going to touch the negative 3, never going to go over it. So when you put it on the graph, I think all of these should be nice points. You got 0, 13, 1, 5, 2, 1, 3, negative 1, and 4, negative 2. And again, it's going to take the same general shape of that graph next to it. Bless you. We are just going to get really close, but try your best just to curve this so it does not touch it, does not go over it. Going to just take everything I've got in the graph right next to it, shift it down 3 units. That's all that's happening there. And I'm just going to scooch this up. My asymptote was the negative 3. Domain, every single one of these is negative infinity to infinity, or if you want to do the all real numbers. Now, your range is different here because we've shifted this graph down. So now I start touching the graph when I hop over negative 3. So my range there is going to be negative 3 to infinity. Anybody have any questions? Okay, just really quickly at the bottom down here. We don't have to graph anything. I'm just going to give you an equation, and you're just going to tell me, like, how does this change the graph of this original? So the original's right here to the side. Y equals 2 times 1/3 to the x. And this very first question, we did not actually do any graphs that look like this today, but we did yesterday. So if I alter that equation just to start with a -2 instead of a +2, do you guys remember what that does to the graph? Like, how would you describe, what does that do if I just put a -2? Remember? Reflection. Okay, so this graph, if this is just decay, I'm just going to do you a little sketch, right? It would look like this. If you put the -2 in front of it, what it does is it's reflected over the x-axis. You just put that little negative in front, it's just going to take the original shape and it's just going to flip it down. Okay, now all the rest of these are what we did today. So if I take that original equation and I'm going to alter the exponent to be x plus 3, how would that shift the graph? Not down 3. Left 3. Yeah, it is opposite. This is left 3. If it's in the exponent, it's going to go left or right. If it's not in the exponent, it's going to go up or down. Okay, so here's my original equation, the 2 times 1/3 to the x, but -6. How would that shift the original graph? That would go down 6. Outside that operation, it's going to affect up and down. Okay, now the last one has 2 shifts. So I've got 2 times 1/3, and then my exponent is x minus 4, and then plus 7. How is that 2 shifts going on here?
Right, up 7?
Yes, this would go right 4, because it's the opposite of what it looks like. It goes right 4, and then up 7. So there's a couple problems that'll ask you just to go and describe the transformation. That's all you have to write, just up, down, left, right. There's none on the homework that are a reflection. I just wanted to remind you of that from yesterday. Okay,